Okay, this is the second out of 3 videos for section 2.3. So if you'll go down in your notes to this part right here, right up above example number 5, let's talk about, we've talked about how to find domain when we have just a list of ordered pairs. We've talked about how to find domain when we're looking at a picture. Now let's talk about finding domain when I only have an equation to look at. How do I find domain when there's only an equation? In general, the domain of a function defined by an algebraic expression is going to be all real numbers. In general, it's going to be, if I have to find the domain of an equation, it's going to be all real numbers. But there's 2 special cases where it's not going to be all real numbers. And so I have 2 questions for you to ask yourself. The first case where my domain is not going to be all real numbers is when I have division by 0, when there's the possibility of division by 0. If I have this, what I'm going to do is I'm going to set my denominator equal, not equal to 0, and then I'll solve. And I'll walk you through how to do that. Case number 2 is if I have an even root. Okay, so this is a square root, a 4th root, a 6th root, etc. Most commonly, we're going to be using square roots. But when I have an even root of a negative number, an even root of a negative number, when I have this, what I'm going to do is I'm going to take the inside of the root. I'm going to make it greater than or equal to 0. Remember, anything greater than 0 is positive. And then I'm going to solve. And I'll do an example of that one for you as well. So let's take a look at example number 5. This tells me to find domains and ranges. For now, I'm going to cut out finding the range part, and I will talk about that a little bit later. I'm going to still write down what the range is, and I'll explain to you why I have it. But for the time being, range is something that we'll talk about a little later. All right, so for part A, we're looking for, is it a function or not? And then we're looking for the domain. Now, if I were to draw this, you remember from previous math courses, something like this is just going to be a line, and I know that because it doesn't have any powers on it. So this is just a simple line. And so let's see here. Is it going to be a function? Yes, it is. I hope that's what that is. Yeah, it's a function. Now, my domain, when you think about graphing a line, we had this one earlier. So if I had just a line like this, my domain is going to be all real numbers. My range is going to be all real numbers. So it's easier to kind of think of a picture when, especially for the range. But here's another way to think about this. Let's go back to our 2 questions. We're going to say that my domain is all real numbers unless I have division by 0 or an even root. Well, when you look at this, there's no division by 0 and there's no even root. So this is another way of saying, yeah, my domain is going to be all real numbers. So let's go to part B. Part B is just a quadratic. We've seen a couple of quadratics in the last couple of weeks. So remember that a quadratic looks like this guy right here. And so first thing is, yes, it is a function. There's no x repeats. The second thing is my domain's probably going to be all real numbers, but let's look at those 2 cases again. Do I have anything with a denominator that might be 0? And do I have any even roots? Well, notice there's no fractions, so none of my denominators can equal 0. And there's no square roots or 4th roots. Yes, there's a square, but not a square root. So we're going to say, yeah, my domain, all real numbers. My range is going to be a little different, and this is going to be easier after I cover section 2.6, which is the next section. So that's why I don't want to get ahead of myself on this, but I'll go ahead and give it to you. My range is going to be from 3 up to infinity. I'm going to skip letter C, but you can take a picture of that or a screenshot and come back to it. I'm also going to skip letter D. Again, these are a little easier once I cover some more sections. Let's go over to part E. Part E. Now the first thing is let's talk about my domain and my range. Or maybe I should talk about function first. I think that's probably what I'm going to cover up or uncover. So yes, this is a function. The easiest way to talk you through that is to look at a graph. You don't know what the graph of this looks like yet. So for now, just trust me on that. So my domain, do I have anything that could make the bottom 0? Is there division by something that could be 0? Well, yeah, depending on what x is, the bottom could be 0. All right, let's go back up to that question up there. Is there division by 0? If that's possible, we want to set our denominator not equal to 0. Set the denominator not equal to 0. So that's the very first thing we're going to do is we're going to take our denominator, x plus 2, and make it not equal to 0. And we want to solve as normal. So when we solve, we're going to subtract 2 on both sides. So x is not allowed to equal -2. X is not allowed to equal -2 because if x equals -2, I'm going to get a 0 on bottom. Now, let's come back to the directions and let me make sure. It just said give the domain. So there's a couple of ways I could write the domain. I could write it in set builder notation. If I wrote it in set builder notation, I would just do my x such that outside of that. That's one way to do it. Or I could write it in interval form. So when you think about the number line, I'm allowed to use every single number on the number line except for the value of -2. And so I'm going to have -infinity to -2, not including -2, or in union with -2 to infinity. My range, again, right now, you may not know how I got this, but basically I thought about what the graph looked like. So from -infinity to 0 and from 0 to +infinity. It's okay if you don't understand that quite yet. Now, I've added another question that wasn't in here that I wished it was so that it would line up with case 2. And so this is the equation y equals the square root of 2x minus 1. Again, I'm thinking of the graph. I know that this is the graph of a function. That is something that you'll learn a little bit better in section 2.6. Now, let's go to case 2 and let's remind ourselves of what it said. Do we have an even root that has a negative number inside of it? Well, it's definitely possible that my x value might make me have a negative number inside the root. So let's look at what it tells me to do. If that's the case, take the inside of the root, make it greater than or equal to 0, and then solve. All right, so let's take the inside of the root, which is 2x minus 1, make it greater than or equal to 0. This is an inequality. We know how to solve inequalities. So we're going to add 1 and divide by 2. So that'll be x has to be greater than 1/2. I could write this in set builder notation if it asks me to, or if I write this in interval notation, this is going to be a domain from 1/2 to +infinity with a square bracket on the 1/2. My range, and once again, I'm just thinking of what the graph looks like on this, my range would be from 0 to infinity. All right, now let's jump into some function notation. So we're going to be talking about y is a function of x. So in other words, I'm going to put x to the job. It's going to do a certain job, and when it does that job, it's going to produce y. That's essentially what that means there. Y depends on x. The way that we say this, or the way that we write it, I should say, is that y is a function of x. This is called function notation. You could read it f of x or f at x, or if you want to say it the long way, y is a function of x, but we don't usually say it that long. F of x is just going to be another name for the dependent variable y. The symbol f of x does not mean f times x. That's a big deal. This is not f times x, but it represents the y value associated with the indicated x value. So that's a big deal on that. All right, so let's put this into practice. I'm going to do parts A and C. Notice that I was given two things. I was given an f of x, and I was also given a g of x. For part A, I only care about the f of x part. Okay, so I'm told to find f at the x value of -3. Notice my x here is being replaced with -3. So then every time I see an x over on this side, I'm going to replace it with a -3. All right, so the first line is going to be, let me walk you through this, a negative, x gets replaced with a -3 squared, minus a 6, times a -3 plus a 4. So now let's put this to work. In this first part here, make sure that you follow the order of operations. -3 whole thing squared is going to be a +9, and a +9 with a negative is going to turn into a -9. So you have a -9 plus an 18 plus a 4. Which is going to equal 13. So f of -3 is equal to 13. Another way to think about this is that the x value equals -3, the y value equals 13. Okay. All right, for f of r, notice that I took all of the x's and replaced them with r. So you'll see this statement here is just simply rewritten with r's in it. For letter C, notice that I'm going to take g of x, let me zoom out a little bit here, g of x, and I'm replacing every single x with an r plus 2. So I'm going to have my 3, my x is going to get replaced with r plus 2, and then I have my plus 1. So we have a 3 times my x, which gets replaced with r plus 2, plus my 1. Let's clean that up by distribution. 3r plus 6 plus 1. So this is going to give me 3r plus 7. All right, let's use function notation. So on all 4 of these, we're going to look for f of -1. F of -1. So once again, all of my x's are being replaced with a -1. So f of, let's try that again, f of -1 is going to equal 2 times -1 squared minus 9. We know that -1 squared is just a +1. So +1 times 2 is just a 2, minus 9 is -7. Over on example B, f of -1. Well, you look here, my only time my x value is -1 is right here. So what's the y value? The y value is 6. So f of -1 in this case is 6. In part C, f of -1 leads me to a y value of 5. And last but not least, in part D, f of -1. All right, so here's the x value of -1. What is the y value there? The y value is 0. All right, so let's talk about finding an expression for f of x. So if you have this equation and it's got x's and y's in it, how do you switch it over to an f of x statement? So the very first thing that you're going to do is you're going to solve the equation for y. Okay, so get y alone is another way to say step 1, get y alone. And then secondly, once y is alone, replace y with f of x. Okay, so let's put this into practice. I've worked out part A for you. You can take a look at that as you're able. I'm only going to work part B in this particular video. Notice that I have some instructions here. First, we want to rewrite each equation using function notation. Notice that part B here has y's in it. It does not have f of x. So we want to rewrite the equation. After we rewrite the equation, we want to find f of -5. And then thirdly, we want to find f of t. All right, so the first thing that we want to do is we want to rewrite the equation using function notation, and we're going to use our steps. Let's get y alone first. get y alone first. So in order to get y alone, I went ahead and I subtracted 2x from both sides. And then I'm going to divide everything by -3. Remember, this is kind of like share the love. So you want to take each of your 3 fractions and reduce each of those 3 fractions. So this is going to give you y equals a positive 2/3 x minus 2. Okay, so step 1 says get y alone. Step 2 says take y and replace with f of x. So just rewrite the equation. Instead of saying y equals, say f of x equals. Okay, so that takes care of the first part of my instructions. The second part of my instructions says that we should find f of -5. So f of -5, I'm going to replace every single x that I see with a -5. All right, so when we follow the order of ops and multiply first, this is going to be a -10/3. And what I did was I went ahead and changed the 2 into a 6/3 so that I could have a common denominator. So -10/3 minus 6/3 is going to give me a -16/3. So this is the second part of my requirement. F of -5 is equal to -16/3. The last thing that I was asked to do is to find f of t. Find f of t. So I'm going to take this statement here, and I'm going to take all of my x's away and replace them or substitute them with t's. And so I'll have an f of t is equal to 2/3 t minus 2. All right, so that's going to be the end of this particular video. And so hang tight and we'll get the third video up and running for you as well.